All right. Hello, everyone. Welcome once again to the final workshop of the special workshop with R, with me, Decola. I'm so excited to have you here. This is the final one. We've had the first and second workshops. You can find those on our YouTube channel. And we're so excited that you've joined us today to round up the workshop with Dr. Lee. And without further ado, I think every other information concerning the community, the Port Harcourt School of AI, and what we try to do is to make world-class AI and data science education accessible, and just democratizing all of those. So if you have any questions about what we do, you can visit our website, phcschoolofai.org. And if you, of course, we have lots of trainings. We have a podcast as well, so you could check out our website for all of those, all in our bid to make sure that world-class AI and data science education are accessible for anybody interested, really, for free, absolutely free. So you could check us out on our digital channels, Twitter, YouTube, and so on for those. But without further ado, I think every other links to the left in the YouTube description if you're watching this on YouTube, so you could just explore. And if there's any way you can support the community, support our efforts with some of our affiliate programs, as well as donating to our cause. We're so excited. So there are links in the description for that. And without further ado, I think we can dive right into Dr. Lee's session. So introducing Dr. Lee once again, he's a course instructor at the University of Maryland, in Baltimore County, as well as a retired U.S. federal scientist in the United States. And of course, we're going to be wrapping up this workshop with using COVID-19 with using R to explore COVID-19 data and probably get good insights from that. So I'll be handing over to Dr. Lee right now. All right.
Okay, thank you, Stephen. Yeah, as Stephen said, I'm Lee Decola. There's a picture of me in one of the bedrooms upstairs, where I've been working for many years. And so I don't think you need to see a picture of me in my ugly face anymore, but there it is. And I'm going to present a window, namely the R Studio window. And please, I'm a very casual teacher. People call me Lee, or at least I try to get them to call me Lee. It says you were presenting your screen. Does that mean you're looking at the whole screen, or you're just looking at the R Studio? What are people seeing right now?
Looking at the R Studio.
Okay, good. So please, if you have any questions or issues, let me know. I'm going to go down and I look, okay, chat. And I can see the chat window. Modu has already sent me a helpful comment, something I'm going to look into. So what we're looking at here is the R Studio environment. It frequently consists of multiple windows or sub-windows, and I've increased the font size from last week. If you've been with us for a couple of weeks, you somewhat know your way around the window. And what I'm going to do right now is create a new script. So I go over to the upper left-hand corner and I type File, New File, R Script. And so what you can see that we now have 4 windows. On the upper left is the script window where I can type in commands. On the bottom is the environment, which reports to us various objects in the R environment. On the upper right is the console window. I've typed my email there, my email address, so perfectly willing to receive emails from people. And then on the lower right is a help screen is a window where help help files, help instructions would appear, or if I make any plots. And one of the things we're going to do to start with is I'm going to load a library, and the library is entitled. Let me just move. Let me do some house cleaning for a minute. I want to look at my notes and look at my script over here. Okay, I'm going to take that down. And so we're going to look, we need to run a library. And the library, so if I type in the command on the command window, I'm in the command window here, and I type in zoo, lowercase z-o-o, z-o-o. It says there's no documentation for specified, but if I type in question mark, let's see, oh wait, oh, because I don't have, all right. So I'm going to need a library, and I'm going to put in my script the command library z-o-o. And then, as you can see on the upper right-hand screen, is a message that says that it attached the library's the package zoo. And if you need to install a package, what you do, and this is the only package we're going to need, the only outside of the basic tools within R, this is the only package you're going to need. So if you need a new package, you can go over to Tools on the upper left-hand corner and click on Install Packages. And then if you type in the letters ZOO in that second window, you probably should find a local depository. Oh, I guess it doesn't matter. It goes to CRAN. Okay. So then you're going to need that package for this exercise. If I'd had a way of posting to our website, I would have told people to do that beforehand. So you're going to need the package zoo. It's actually not a package consisting of wild animals. It's a time series package. So you hit enter, and I'm not sure what's going to happen to me. I've already got it installed, but one of the more packages will be updated. So it's currently loaded. Prior to restarting, strongly recommended. Okay, I don't want to restart R. So what you're going to need to do is go to Tools, Install Packages, and then in the second bar of that window, type the letters Z, Oscar, Oscar, or Zebra, Oscar, Oscar. And you're going to need to install that package. We're not going to use it right away, but we are going to use it in a few minutes. So let's put up a URL. Well, let's just install our data. Actually, let's put a title up on the top of our analysis of U.S. COVID data from usafacts.org. Okay, so there's a comment on the first line of our screen. Pound analysis or hashtag analysis of COVID data from US Facts. So I'm going to save this file on my desktop just so that if anything happens, this machine has been crashing. So I want to make sure I'm going to go to my desktop. You probably can't see me do that. And I'm going to type in COVID_analysis.r. And it's on my desktop. There it is. Okay. So it's saved. So I'm going to read in some data. I'm going to use the command over here. Let's look at read.csv, comma, delimited values, comma, something. And if I also figured out a way to make that bigger. If I go to Tools, someone told me and I've forgotten it. Oh, let's see. Tools, Global Options, Advanced Help Funnel Panel. Let's make it 16. Okay. So there's the. All right. There's the make that bigger. So on the lower right-hand corner is a help file for read table or read.csv. You can see that it gives you help for read table as well as help for .csv. CSV is comma something values, comma separated values. All right, so here's how to read CSV. It says if you want to read a CSV file, you put the name of the file in, and then there are several defaults. But basically what you need is read CSV. So if you type in read CSV .csv without any arguments and you hit read, it says file is missing. So I'm going to give it a file. I'm going to give it a URL, and the URL I'm going to give it is in quotes http://eldecola.net, and I'm going to make that window more visible. Please, if you're having any trouble following the commands or hearing me or understanding something, there are not that many of us. I don't see. We have 6 people, so I'm one of them. So let me know, and I've put this data in a directory called files, and the name of the file is covid.csv. So if that command has worked, I have to give it an object. So I'm going to call it COVID. All right. So there's a command, and if that command is successful, R has gone off to that URL, http:// so on and so forth, and it is burrowed down into the files directory in my website, and then it has gone and read the covid.csv file. So I'll hit Control Enter, and it says on the bottom left of our studio window, it said that it read 147 observations of 3 variables. And typically what I do is when I've created a new object, I try to investigate what it looks like. One of the easiest things to do is to type head, and you can see on the right hand side of the screen, so I'm going to make the whole screen bigger. I hope that, I don't know what that does for people. Again, if you're having any trouble seeing stuff or understanding things, just put in a chat. I have the chat window just to the right of our studio window. So we can see that on the upper right hand corner, we've gotten a report from R that the object COVID is at least 3 columns of data, and if I actually want to know what kind of an object it is, I can type in class COVID, and it tells me it's a data frame. I can find its dimensions. I already know those, but still. It's 147 rows by 3 columns. If I want to know a little bit more about its structure, I can type in str COVID, and that's no, the chat window just disappeared. Did I do that? Why would the chat window disappear? I don't know. I'll leave it. So it says that it's a data frame with 147 observations, 3 variables, the date. Now let's look at that date row. It says that the date is a character variable. The first value is, quote, 2020-01-23. And let me just dwell on that a minute. I've created this data set. I created it from the usafacts.org website. They had formatted the dates in a different way, but I've formatted the dates just as you would format a number, with the big values at the beginning and the smaller values at the end. So the first 4 characters represent the year, separated by a dash, and then the second 2 characters are the month, and then the last 2 characters are the day. So it's very logically organized. Years are bigger than months, are bigger than days. But if I do a summary on this file, or in this object, so I'm going to make the script window a little smaller and the console window a little bigger. If I do a summary on this file, you can see what it does is it summarizes as best it can information from the 3 columns of the data. And again, it reports that the cases have the minimum value of 0 and a maximum of 37,400. And the deaths range from a minimum of 0 to a maximum of 3,164. So I want to focus on date for the moment, and we'll come back and look at the cases and deaths. So date is a character value, which is not of any, it's not of much value to us as a analytical tool. If we're going to do some visualization, we need to have date represented as some kind of a numeric object. And but so let's just clean that up and so what we can do is we can actually take COVID date. The way I reference, let's just show you, see. So the way you can reference a specific column in a data frame is by referencing the name of the data frame followed by the $sign, not the Naira sign, followed by the name of the variable. So I've just gotten the first 6 values of date, and what I'm going to do is I'm going to transform COVID date over in my script, and I'm going to assign it the value as date COVID dollar date. And as I said, as I always said, if what you've done is correct, then you don't get any response from the screen. And again, we didn't get a response from the screen. If I go up a couple of commands and type in summary COVID again, we get a very different result for date. Date is now shown as a minimum of 2020-01-23 and a maximum of 2020-06-17, which was 2 days ago. So what I did was I went to the USA facts. You're not seeing the end of the console to the right. Osuwalale said that they're not seeing the console. I'm not sure yet. Stephen asked, are you on a mobile phone? If you're on a mobile phone, what's the answer, Emmanuel? If you're on a mobile phone, maybe you are having trouble. I think is everybody else able to see the entire screen? The 4 windows?
I can see the screen.
Okay.
It's just the last window, but I don't really think that's significant.
Yeah, okay. All right, so what we've done is we've transformed, we now have, and I'm not going to go into any great details about what dates are, although it's a fundamental problem in understanding time series analysis, but we now have a data frame consisting of 3 columns, and if I go back to str here, I'm just going to move around the commands I've already typed. It says that we have a data frame consisting again of 147 by 3, but now date is shown as a date class, and the 2 other variables are shown as integers. So we now have a date. And what do I mean by that? Well, let's just spend a few minutes looking at date. For example, I can look at range COVID cases, and it says, as we know, it ranges from 0 to 37,400. Now that means that for the data that I uploaded to my website, the 147 rows of that data frame report for each day the number of cases, and those cases range from 0 to 37,000. So which means that probably recently, we don't actually know what the behavior of that variable is, but if it's an epidemic that's in the process of unfolding, that large number is probably occurring recently, and the smaller numbers appeared earlier. But we can do the same thing with date. And it says that the first date value is 2021-23, which is January 23rd of this year, and the last observation, or it's not the last one, but the largest observation, which also happens to be the last, is June 17th, 2 days ago. Today's Friday, so that was on Wednesday. Great. But I can also, for example, look at the difference of the range. So I'm going to go up and type in DIFF, and I'm going to put a close parenthesis. So what I'm asking R to do is compute the difference between those two values, and it does an interesting thing when I type Control Enter. It says 146 days. So it's able to interpret that difference of days into an actual value, which consists of 146 days. So say, instead of going to a calendar and asking how many days there are between January 23rd and June 17th, it gives us, it does the computation for us. And if indeed the days were if the difference in those days was much larger, it might report the difference in years. I'm not sure it would report it in months and so forth. So it has now transformed that data into a I'm zooming in over. It's transformed that date into a date object that we can do some computations on. Let's go back then to the so we now have a data frame which is a date object and two integers. Let's look at the case data. I'm going to put up a command, and now I'm going to put up a comment description of totals. So let's look at the totals. So let's look at some COVID cases. Let's look at deaths. So what it's done is it's taken that column, and if I hit, it says that the number of deaths that have occurred in the United States, the number of reported deaths, and again, when I teach classes on epidemiology, we spend a lot of time on the difference between the reported deaths and the actual deaths. There's been a great deal of controversy in the U.S. about whether all of the people who are dying of COVID-19 are being reported as having done so, and it's not an easy decision to make sometimes to report what the cause of death is. But it says that over the course of the epidemic so far, we have had in the U.S. about 117,000 deaths. And if we wanted to look at the number of deaths divided by the number of cases, we can see that the ratio between the total number of deaths and the total number of cases is about 5.4%. And I could round that off. Let's just do that. If we wanted to give somebody a report, we could hit round, and then I'll round it to two figures. And it's 0.05. If I wanted to multiply it by 100, that's 5.44%. All right? So we know that roughly, and again, I can't stress enough times that the chat window keeps disappearing. I can't emphasize strongly enough that this is just a matter of what's being reported to us. We don't actually know what's going on in the real world. So we've got a death rate of about 1 in 20 people. So, but obviously we know that, or at least I know from reading the literature, that the death rate for older people is considerably higher than that for younger people. And we're not even sure. Some of these cases may be double cases. There may be people who are reporting. I heard yesterday in a chat I was on that sometimes people are repeaters. They're actually able to get COVID more than once. So we don't really know whether those cases are unique cases. And let's see, we can also do, let's look at the, all right, let's divide the case, let's look at the number of cases. Let's get rid of, I don't really need this. On the right, we can see there it is. I'm going to make that bigger. We don't really need that. So we have 2,151,000 cases. And I know that the population, let's put in over here above our script, US pop. Well, I know that the United States population is approximately 330 million. All right. Now that's a big number. It's about 1/3 of a billion. And I hit Control Return, and now I have over in the console window, US pop, and it says, oh, 300, I can't, R is saying I can't read all those zeros. It's just 3.3 times 10 to the 8th. It's a little confusing that R uses the letter E to represent exponents, because sometimes the letter E is also the base of the natural logarithms, but it says that it's 3.3 followed by 8 zeros. So I have US pop in memory, and you can see it down there. So I only have 2 objects in memory so far. I have the COVID data frame and the US population. So I can divide the sum of cases by US pop. And it looks like it's about 0.6% of the population. Close to 1, it's getting up there close to 1%. And I could clean up that ratio to make it a percentage if I wanted to as well, but we don't really have time to mess with that. So I have a kind of a dashboard here for COVID data for the United States. I have totals for cases, I have totals for deaths, and I have a time series. Let's look at the any questions so far? I'm going to take a 2-second break and a 15-second break and ask for questions on the chat window.
Hello.
I heard it sounded like somebody talking underwater. Everybody have access to chat? Okay, somebody said, hello, Dr. Lee. Hello, Oyediran. That's not a question, but it shows somebody's out there. Let's hear a question. Somebody, I can't see something, I don't understand what you're doing, it doesn't work for me. Someone's using R on an Azure notebook. Is an Azure notebook a nice blue color? Azure notebook. Okay. Line 13. I'm not sure what the line does. Diff. Okay, good. Thank you. This command. All right. As I said, the first command I typed was the range of COVID cases. Let's just look again at COVID cases. Date. All right, so those are the first, they look like character values, right? But they can actually be turned into integers. If I could I could actually call it as numeric. So look what happens when I do that. When I transform the first 6 values of COVID date into a numeric value, it turns it into a number which clearly increments by 1 for every day. So it's actually turned what we viewed up here in the console window as what looked like a string. It was able to turn that string of numbers of 9 characters into a number, 182.84 days. And how many? So if we divide that by 365.25, that's 50. So it's 50. It means that our clock started about 50 years ago. All right. So we're actually numbering days from about sometime in 1970, which I think is actually true. So if we go, well, all right. So what I've done in this command here on line 13 is I've computed the range. I'm sorry. I didn't do the right. Oh, good. You found a mistake. What I computed here was the range of COVID date. So let's type that command. That's the range. First date is January 23rd. The last date is June 17th. And then it computes in line 13 the difference in that range, which is 146 days. I hope that explains what line 13 does. It does exactly what you'd expect it to do. What's the difference in between the 2 dates? And it says, well, you could also do it in seconds or minutes or hours or whatever. You know, if we multiplied it by 24, it would be probably would give a misleading day. Yeah, that's misleading. It should actually be hours, but who would know? You know. All right, that's probably confusing it. All right, so we've computed the sum of, in line 20, we've computed the ratio between the sum of the cases and the pop. We could actually multiply that by 100,000.
Hi, Dr. Lee. I think you have something in the chat window.
Yes, I read it. He wanted an exploration of line 13.
Oh, okay.
So and then he said he was satisfied with my explanation. So what I've done is typically in epidemiology, small numbers are represented as rates per 100,000. So I've computed that, in fact, I'll round it off to no decimal places. So we have a rate of 652 per 100,000 population. That's typically what's done with epidemiological data, 652 cases per 100,000 people, which means that if you took a random sample of 100,000 people in the United States, that you'd find that 652 of them would have suffered from COVID-19. Let's another thing we can do, because we now have if I plot cases, I just make a plot of those numbers, which is essentially a vector. I get a plot, and let's make this bigger. Let's see, PAR CX equals 1.5. I've gotten a bigger index, and let's plot that PCH equals 20, 16. Okay, there's a plot of the COVID case data shown as a vector of integers. And you can tell that it's not a time, it is, I mean, maybe you can or can't tell that it's a time series, but R doesn't know that it's a time series because it plots on the x-axis, it just plots the index. It says the first value is plotted as a dot, the second value is plotted as a dot, and we can see that by about the 50th, around the 50th index, and we know index is days, So we could actually label that. So I'm going to clean it up a little. Let's actually type it as a line. Type equals L, and let's put a x-axis, x-label equal day, and a main label and again, I'm not used to working in such constrained circumstances. I'll just plot that in a minute. And let's make the line widths bigger. 2, what does that do? Does that make everything bigger? Yeah, let's make it 3. Okay. And so if I zoom this, does it make it, you can actually see it as a freestanding plot? Everybody can see that plot? Keep having to reopen the chat window. So you can see a freestanding plot in the middle of the R screen, the R Studio screen. So what I've done is I've plotted those cases as a line, a series of lines. But with the days labeled, but I don't know what those days are in terms of dates. I mean, I could look it up, but the plot's not showing me the dates, the actual dates. So let's do one more thing, and then we'll plot the, let's plot the cases. Let's see, we'll plot COVID. I'm going to stop and I'm going to type this out and make sure it's okay. And R is telling me that I've got an error somewhere because I haven't closed that bracket. And the errors disappeared. So what I've done is I've asked R to plot for me the date variable on the x-axis, the first column of that, or the second column of the data frame, and to plot on the y-axis the number of cases. And now look what's happened. So is it easier to see? I guess it's easier to see that. So let's talk about what we see there. I mean, that's a pretty good plot. If you put that in a paper, people wouldn't object too much. I might clean it up with, let's see if I just put x lim, y lim equals C0 to 40,000 for E4, comma. Now is it going to, let's see what happens. Yeah, okay. I'm going to stop there. Somebody said how you can change the height of the graphic. You can just pick it up and move it. If I assume if that's what you mean by the height of the plot, I'm going to call this a plot. This thing that's floating around. So let's talk about what you see there. Give me some chat. Give me some lip. Give me some feedback. I'm waiting for either somebody to speak, unmute themselves, or to type a question or a comment in the chat window. Shift the plot window. I'm not sure what that means. Like this way? Now we've got two plots. You can see one in the R window, and then there's one floating around. The other way. Well, I'm not sure it makes sense for me to be trying to adapt my presentation to the person in the audience with the most confining viewing environment. Let's hear some substantive comments about what is being seen there. Let's not do the one. Let's just use this. Let's just make this bigger.
I think the rise in cases from April, I think, is quite evident in the plot.
Yeah, there was certainly nothing going on, not very much going on between, certainly for the month of February.
February to, yeah. To just before.
Things took off in the middle of March. Okay, anything else? Let's hear from somebody else. We don't want to hear from the dean of students too much. What is your title? President of the university?
I guess the dean.
Oh, the dean. Okay. Anybody else?
Okay, sir.
The daily number of cases has been reducing gradually over time.
I think the best thing to do would be to type in messages in the chat window. There's a lot of noise on that line. Anybody else give me some comments about what you see? I mean, this is the data set we're going to be looking at. You can look at deaths on your own, but we're pretty much going to be looking at the case data. I'm waiting for a chat. Well, I don't want to go on because then it kind of inhibits people from looking at things. See a decline. Yeah, it's hard to see, but it looks to me as though you're right. There is a decline in cases from, say, if we look at the beginning of April, it looks as though there is a decline of cases through April, maybe not through April, but certainly through May and June. It looks as though there's a decline, but then maybe things are picking up again in June. We're gonna investigate that very problem in a few minutes. And also, the data bounce around a lot. You know, there's a lot of variability from. It looks as though, I mean, if you look at the x-axis, I mean the y-axis, one of these ticks, the difference between one of these ticks is about 10,000 cases. So it looks as though there's a bunch of. It jumps around by 4, 5, 6, even 10,000 cases from high to low, and we're going to try to filter out some of that data. But the first thing I think I'd like to do would be to subset the data, because I'm not really interested in all of those variables, all of those values before say March 15th. So let's take the first thing I'm going to need to do is I wonder if I can get away with. How many people are actually running the code? Is anybody out there running the code along with me? Actually doing programming? Okay. All right. So in that case, okay, good. That's great. That's good. So in that case, what I'm gonna do is I'm gonna transform the data into a zoo object. So I'm going to put in a comment here, make a zoo object. And I'm going to call this thing .z. And I'm going to use the command, I'm going to go back, ZOO parenthesis. And I'm going to take the I'm just going to take the cases. Cases. And I'm going to have to tell R what that what the date is for those zoo objects. So I'm going to just do the obvious thing and call it COVID date. And I'll make sure I've closed my parentheses. I'm going to put some command. Give myself some space. So what I've done is I've created a zoo object, and again, if I want to know how to create what zoo objects are, I type question mark ZOO, and I get a help file for zoo. Ordered observations. I don't know where zoo comes from. And here's all kinds of descriptions on zoo, and here's a very detailed, at the bottom of that help file is a very detailed set of examples that you can run on zoo. So if you want, typically if I learn a new, if I want to learn a new tool in R, I go to the help file and then run the examples. So there's a very good, very useful tool. So this is a zoo object, and if I hit return, control enter, I should get the fact that I have a zoo series. And now when I type in, do I want to plot it? Yeah. Let's type in, well, let's just look at what it is. And it says it is a zoo series from 2020, January 23rd to 2020, June 17th. And the data start at 1 and go up to whatever. And the index, so it actually tells us the index for each one of those observations is a date whose first value is January 23rd. And now when I plot the data, I don't have to do all the stuff I did before. When I plotted it as a data frame, I just plot. And it plots it with the date on the x-axis and the values on the y-axis, and it plots it as a line. I can type line width equal to 3 and type equal to overlay, and it plots it as it's a little clunky, but it's okay. Again, I'll zoom it up. And now I can see the same data, but now it saved me a lot of trouble. It says, okay, I've got a time series object here, a zoo object. I should put on top of the as, let's look at, let's see, max time COVID.z. So that says that the data is, the last observation was 2020, June 17th. So what I'm going to do is I'm going to plot on my graphic, I'm going to type a label, main equals COVID cases as of 2020, June 17. Okay. I misspelled COVID, but that's okay. I'm going to close that. Again, chat disappears. Okay, I hope, were people able to load the zoo package? Okay, good. Great. So that shows that you can, it's very encouraging. I mean, you know, when I was teaching in Nigeria 40 years ago, I mean, look at how far we've come, and you guys can sit in your dormitory rooms or your homes or your cars and download packages and run time series analysis. I mean, you need to be an old person to appreciate how far we've come. What I can also do is I can actually paste that. If I wanted to, if I ran this script tomorrow or a week from now, so I'm going to do paste COVID cases as of and then I'm going to follow that with the max time over here. I'm going to close that bracket, and I have no errors. So I was able to, I guess let's try it, right? Okay, so I was able, actually I don't have to type in the time here, the last time variable. I know, so people looking at that plot can see that the observations are complete as of 2 days ago. So I don't have to type in the date anymore. It just reads the date from the data. So as I said, I'm interested in, there's maybe a third of those observations are not very relevant to my analysis. So what I'm going to do is I'm going to put in a vertical line at, I'm looking at my notes here, AB line, B, oh wait, let me, what do I want to do? All right, let's not do, let's shoot. All right, let's do this. Let's go back to this command. Let's look at what are the Mondays. So if let's just head format COVID date or time COVID Z. Let's just actually look at let's just look at the head of COVID Z to start with. The time of COVID Z. Sorry to be doing this to you, but let's look at the head of that, HEAD, the time. Okay, so it just prints out the first 6 values. And I can format that. That's a date value. Those are date values. I can format that using a format of %A . So if I complete, all right. So what it says is it takes those 6 values, which are the first 6 values of the time value, and it's formatted them. And I'll show you what happens when I do that. It says, okay, I know what the day of the week that is. So it's taken that time. And again, if you want to know what we're doing here, question mark format date, I think. Yeah. Okay. And then it gives you a whole bunch of instructions on how to format dates. So you can see I've used I mean, I'm not going to get into the details of object-oriented programming, but I've just typed a question mark, and the command I typed up here was, what does R do when the command format is run on a date object? Now, I'm not an expert in object-oriented programming. I think that was the last thing I tried to learn before I became a senile old man. But so that's what the period there tells us, that we're looking at the format command as run on a date object, and the help screen below that tells you various things you can do with date objects. And so what we've done is we've been able to translate that, the first 6 values of the date into days of the week. So let's, where's our plot? Here's our plot. Let's go back to our plot, and let's type let's put a vertical line for every Monday. So I'm actually going to type in here. Let's do this. Let's take Monday equals, or is equal to, COVID date. And let's select those COVID dates. %A are equal to, I'm really running out of space here. I'm going to move this over. Is that a correct COVID date format? COVID date equal to A. It's not working and see COVID date format. Let's see. Oh, wait, no. Let's do time. Oh, it was time, right? Time. Z. Time, go ahead. Z. Equal to Monday. That's not, there's some error there. Time, COVID Z. That's time, COVID Z. Where format COVID Z is equal to, I don't know why it's giving me an error message. Or maybe the next line is giving us an error message. This line is giving us an error message. Nope, it's still showing up. Why are we getting an error message? Oh, I didn't put a, that's right. I'm not used to using RStudio. It's very helpful. It tells you where your errors are. Equal to underscore mon. All right. And those are all the Mondays. So if we look at Mondays, we have a list of Monday. We have the dates of all the Mondays. Okay, and you can see that the first Monday in the data set is January 27th. The second one is February 3rd. The third one is 7 days later, February 10th, and so forth. That's so that command says take the time values for COVID Z and take the format of COVID Z as days of the week and give me all of the values for which the format of that day is, or the day of the week is actually Monday. So those are the dates that are Monday. And now I can type in AB line B equals Mon. And those are all of the Mondays. You know what I want to do? I'm going to, well, all right, I'm not going to make, I don't want to confuse people. Yeah, it's about, at my end, it's about, so we have about 25 more minutes. So what I've done is I've drawn a vertical line for every Monday. And now I can begin to see that the cycles in there are a weekly cycle. In fact, for the first few months in weeks in April, I can see that there's a minimum around Monday. And then just to expand this even further, I can see just, we look at that big, let's see, the third week in April, we can see the maximum there. So there's a low value on Monday, an even lower value on Tuesday, Wednesday, Thursday, Friday is a maximum. Saturdays, it goes down and goes down. What I would like to do is, and I know that's a pretty, but I'm gonna put this code online for people to look at later on. I didn't want to make it available right away because I wanted people to follow along with me. But you know what I would like to do is, take the recent data. So what I'm going to do is, I'm going to take recent data and I'm going to let it equal to COVID.z, the time, greater than or equal to. Should have done this earlier, but 2020-03-16. So let's call it recent.z so I know it's a. So what I've done is I've said, give me all of the and obviously I'm throwing this bracket notation at you. What inside the bracket, oop, I don't want to move that. Inside the bracket I've said, give me all of the, inside the bracket is a logical expression that says, for any value for which time of COVID Z is greater than or equal to March 16th, which is actually a Monday. So I want you to subtract or extract those values, and I hit Control Enter, and now I've got recent. I'll plot it. And let's use all of my, actually let's just use the command I did over here. I'm going to go back to this string I typed here. So it's going to call it recent. And let's change that to recent. Oh, .z. And now we have the data from starting in March 16th. And you can see that, you know, if what we've chopped up is just the first few dozen or few couple of months where almost nothing happened. So now we're really looking at the important part of the data set. And again, I can put those Mondays up. I'll go up to AB line. AB line means it's an alpha, an AB. It's like a regression line, but in this particular case, it's a vertical regression line. And I'll go to my plot and I'll zoom. So there I can see much more clearly that the data are on some kind of a weekly cycle, and that minimum occurs pretty much around Monday of every week. And again, as I said, all this script, all of this code will be made available. I'll put it up online maybe today, or if I go kayaking today. It looks like it's pretty nice out, so I might go paddling this afternoon. So, but this is the kind of plot that you could very well put into a paper that you were publishing or for submitting to a class or a newspaper article. Might want the vertical lines to be a little bit smaller and so forth. So let's filter these data. Let me see, where am I on filter? Okay, good. Up. Let's put a filter on these data. No filter, I don't have a filter. I'm going to close that plot. And let's put in a comment. Oh, I see. That's what happened. When I had a crash a couple of days ago and my computer crashed, I lost some of the coding I was writing. And last week we talked about filtering, so let's just talk about it again. I'm gonna call my filter just call it F, and it's equal to repeat the number 1 7 times and divide it by 7. So if I look at F is just the number 0.143 7 times. So I'm going to repeat, I'm going to pass over that data. Let's look up filter just to make sure we know we're using it right. I think I can, do I have to run it on time series data? Yes, it has to be done on a time series data. Okay. So I've got a filter there, but if I want to run filter, I have to run it. So let's see if I can I transform recent.z? Can I transform it in a time series? ASTS as time series. Dot T equal to, will that work? Yeah, it does. Okay. It's still a time series plot. There it is. Okay, look what happened. It threw away the time values. It kept them as integers, as days from 1970. That's okay. I'm interested in filtering anyway. So let's do a filter. It's going to make it a time series. Filter. Using my F. And let's plot the filter. I don't really like the fact that those labels are not showing anymore, but let's just discuss it in the abstract. I don't care. I mean, this is research. This is not. We're kind of flailing around here. We're not flailing around, but we are exploring the data. So what I've done is I passed a filter on the data, and a filter of Windows 7. So what it does is it's called a running mean, or it's called a running mean. It's called a moving average. It's called a filter. We looked at one of those last week. So what do people see here now with the weekly filter on the data? The fact that you're not hearing my voice means that I'm waiting for a response. It's not exactly a weekly average. I mean, that's a good answer, but it's a weekly average would just be taking each week. We're going to look at we're not going to look at that. Well, we might look at that in a minute, but I don't think we have time. But it's a filter that uses it looks at the first 7 days of the data and averages them. Then it moves up 1 day and looks at the next 7 days and averages them. So there's one observation for every day, but the observation, the filtered observation, is is the average of the next 3 days and the previous 3 days and the day we're in. That's what the filter is. So if you look back at the filter itself, which I call wow, somebody said wow, that's nice. I like that. Wow, good. It's good. Yeah, I think what we really want to do is what did I want to do? I wanted to make that. It'd be nice to have the date there. How can we get the date? I made it a time series starting with now. How did I get a date? Let's make filter a zoo object. So let's make filter.ts. Let's make it .z equal a filter of, and then make it with the time. Okay, make it a zoo object, ZOO, and let's go back, comma, and then let's give it the date .z. It sounds like somebody's drowning underwater. Is that going to work? It did work. Let's call it times Z. Okay, good. 3. And let's give it a name. Moving average. 7. So there is the moving average, and let's give it some nice. This is about the last thing we're going to do today because we only have about 10 minutes. xlab equals nothing because we know it's a date, or let's say as paste as max time z. Is that going to work? One thing I don't like about R is the way it, and let's give it ylim equals C0 for E4. And let's do one more thing. Why do we have an echo? I don't know. Oh, that's from paste, I guess. Okay. Let's see if this will work. Can I rotate those numbers? Yeah. Okay. So now we have a better. Why is it not zooming? Do I have zooms floating around my? Oh, here it is. Okay. Get rid of that one. Go back to RStudio. Zoom that one. Okay. So now we have a pretty decent plot. We have the dates there, and we can see what's going on. We have the first of each month is labeled, and what's happening. It looks as though we have an increase in. Again, the chat's disappeared. There was a decline from the peak in April. Yeah, it looks like there's a peak around the first week of April, another bump around the end of April, and then a steady decline until about the middle of May, and then a increase, and then an increase about last week. Okay? I mean, I think that's a profoundly descriptive data set. You know, I mean, that really, it filters out the noise, and it's very powerful. We can see that we can see from the y-axis that we're looking at a maximum of about 35,000 cases back in April, but you know, we're not that much below that now. In fact, I can even put a AB line horizontal equals, let's see, 1 to 35, 1 to 40, 1, 2, 4 times 1,000. Is that going to work? No, 10,000. And we'll make that equals gray. Line type equals 2. Okay. So I've got a grid line. It's a little clunky, but you know, I can see that we had a maximum of about 32,000 cases back in April, and we're down to about 24,000 cases in June. So, you know, certainly if I were the head of the Centers for Disease Control for the United States, I would be mightily disturbed by that trend. I think I have time to do one more. Do I have time to do one more thing? Let me get.
It's just. I think it's 10 minutes left because we started by 3:05.
Yeah. Right. Okay. But still, I'd like some more comments on what people see. What either suggestions, something they might change, comments about what they see, questions about what we've done. Made the plot lines even bigger. Did we get the, where's the chat? I'm enjoying the lecture. Good. Any technical questions, either about what I've done or what you're seeing? Okay, LAS, good. Good. Well, the other that is a good question, and I'll answer it in two ways. First, I'll give you the simple answer. It tells you if we type in LAS equals 2 and run the command again. Run the command. We get the text is rotated a different way. If we type in equals 3, it rotated it a different way. So it's a way of rotating the text. And I know that if I type in 2, it's going to rotate the text so that it's perpendicular to the axis. I think I messed up the dates there, but you know. So another thing, if you want to type, I think if you type in LAS, what'll that do? No, I don't want it. I want LAS. No, question mark, LAS. I don't want last warning. I just want LAS. Okay. Nope, it didn't help us. Let me just tell you that that's called a graphical parameter. So if you type in PAR, you get information about graphical parameters. I don't know whether I can zoom the window. Let's just make that bigger. So these are the graphical parameters, PAR, and one of them is LAS. It's the style of axis labels. I don't know what it, you know, I don't know where LAS comes from. Labels, axis, style. Maybe, you know, LAS, label, axis, style. So it's a way of, I mean, that's a good question. It's a way of rotating the axis, the labels, so that they're horizontal. All right, there's one more thing I want to do. Yeah, the moving average. Yeah, that's really important. Understanding moving averages is really, really important. In fact, if I plot the data on top of the, let's just do points dot z. I want to plot the data on top of, you know, there are the data as points. Okay, there are the data as points, the actual data, observations, and there's the filter right through them. So much more clear. It's so much clearer to see the filter than it is to look at the date. And so let's see if we can understand a little bit more about this cycle. What I'm going to do is I'm going to do what's called decomposition. And in order to do that, I'm going to create a I'm going to create just call it, let's see, COVID.week, and it's going to be a time series of recent, and it's going to start on week 11. I don't know, I'm just going to put 1 here. I don't really, and it's going to have a series of 7. Is that going to work? Recent, oh, recent.z, .ts, what was it, recent.t. And there it is again. I'm going to plot it. Oh, that's not right. No, it is right, I guess. I'm not sure. Oh, maybe it's 11. Now, you know, this is at the end of the lecture where I start flailing around and making mistakes. Recent start equals 1. Frequency equals 11. Oh, I see 1. 11. Frequency. Yeah, that's what I wanted. All right. So what I've done is I've said instead of plotting the data as daily data, I want to plot them as weekly data. And so I've told R that I want a time series which starts on week 11 and is has a frequency of 11. So in other words, it's the same data, but it's now grouped into groups of 7. And I'm going to just do a quick decomposition. So what I've done is, you know, I've thrown a lot at you towards the end, but what I've done is I've created a time series. I've told R that the time series is measured has some kind of frequency. For example, if I were looking at economic data, I might want to group them by month. If I were looking at quarterly data, I might group them by groups of 3 months. So what this has done is it's decomposed the data. So on the top there, you're looking, and this is the last thing I'm going to do. On the top, you are looking at the data itself, the original data as a line. The third row you're looking at is the weekly cycle. So it's extracted from the data of the weekly cycle, and the second row you're looking at is the trend after the cycle's been removed. So it's a kind of a filter, but we're able to see that weekly cycle quite clearly. And we're just about out of time, but I'm gonna cut to the chase. And yesterday I was on a chat and I asked somebody why this weekly cycle, and somebody said it's because the hospitals do testing all week, but they try to complete all the test processing by Friday. So what you're seeing is that there's a drop on Monday, and then by Tuesday and Wednesday and Thursday and Friday, by Friday the peak number of tests are processed and reported. So what you're looking at is the weekly cycle is an artifact of the way the hospitals are doing the testing, and not the fact that people are getting sick on Friday. So as I said, all these commands will be in a script. I mean, if you've typed in what you've if you've typed in what you've looked at, you can also save it. But I'm going to save it and then clean it up. So it's now saved on my desktop, and if I open it up in Notepad or any text editor, I can see it as a text. And I'm going to open up the chat window. So I'm basically done. I pretty much did everything I wanted to. And good question. The last plot is the random. Yes, it says random. It's basically the first row, the first data graphic. The first visualization is the data themselves. The second is the data with the seasonal, or the so-called seasonal component, the weekly component removed. The third row is the weekly component, and then the last row is what's left, the random component. So to type in, I'm going to just put a comment here. It looks, so in terms of the idea is that the data equals it looks like some kind of model plus seasonal component plus a random. So that's really what's showing there, is that the data on top is composed of the model, which is some kind of simpler trend, and then a seasonal component, and then some kind of random variable. Yeah, that's the answer to Oyediran's question. Okay. Stephen, you're the moderator. It's time for you to shut me up and say goodbye.
Well, not shut you up, because you've provided a lot of valuable knowledge for us today. Yet again, thank you so much, Lee, for your time, your efforts, and I think this concludes the workshop on time series with R. Any other workshop, of course, will be communicated to everyone who attended. So just for as a thank you for attending, that's for the participants. I think NASA Space Apps provided free 90-day access to Tableau. I'm not quite sure the details of that, but any freebies from NASA Space Apps, I will share it with the participants. That's for everyone who attended and registered. So you can, I think the highest gift, the freebie, is 90 days free access to Tableau. So I think that will be communicated to everyone right after the workshop. And once again, thank you so much, Dr. Lee. Does anybody have any additions, subtractions, how we can improve next time if we have a workshop like this? Yeah, because definitely you're part of the community now. So we're going to be sharing most of our other community endeavors with you, so that you can, whether it's opportunities, this could be job opportunities, or hackathons, or any other thing that can really provide you your ability to apply your knowledge, per se. It could be PhD scholarships or anything. So, for anybody, do you have any feedbacks? Now you can unmute yourself. Feedbacks for Dr. Lee, the community. Anyone?
Hello, Dr. Lee.
Yes.
Thank you very much, sir, for the lecture, sir. So, how do we reference you with this stuff now? want to share this with someone possibly. Can we share this what we learned today? Can we share this with someone? Anybody?
I'm afraid it's hard. It's hard for me to hear you.
Emmanuel, I'm not sure we can hear you properly. Can you speak loud or type? Is it possible?
Okay. Can you hear me now?
I can. It's a little bit better.
Okay, I wanted to ask if we can share this notebook that we used today with anybody that maybe is interested in learning about these things.
Yeah, sure. Yeah. Yeah, the scripts are, public domain. They, I'd have no proprietary interest in any of the. R is open source software. It's free, and my scripts are certainly there for the taking. Yeah, I mean, it'd be nice if you gave credit. Tell people where I am. I should probably put my email on all of them.
Yes,
that's a good idea. Okay. Yeah.
I think the recording will also go up after today, probably 24 to 48 hours. We can't promise 24 hours anymore because of workload. But the recording should go up probably by the end of this week or Monday, anyhow. So the person can always access the recording on our YouTube channel, just for analysis sake.
And if anybody is able to do analysis of other data sets, I mean, we didn't look at the death data. You could look at the death data, do the same analysis and certainly anybody who's got access to data either from the UK or from Nigeria or wherever you're living. I think somebody was from Senegal last week. If somebody could do analysis data you could get from your own local health departments, that would be good too. All right, I'm going to go sign off and have breakfast.
All right. Wow.
All right.
I think. Thank you so much, Dr. Lee. So I'll send other correspondence to your email, and on our podcast as well. So every other person you receive an email from us. So I think you can catch up on everyone else while Dr. Lee signs off. And catch up with.
Thank you. Thank you very much.
All right. Signing off.
Thank you very much, Dr. Lee.